which choice ranks these compounds from strongest to weakest acid? Right? We determine strength of an acid by the stability of its conjugate base, right? The more stable its conjugate base is, the less stable that conjugate base is to pick up a proton, shift the equilibrium back over to the side of the acid, right? So when we put that protonated form of the acid in the compound, it will shift over to the side of the conjugate base, lose its proton, because that conjugate base is stable. So, adding to that, there are a few things that we know from, I believe, chapter 2 or 1 in the book about what determines the strength of an acid by being things that are able to stabilize the conjugate base. So there's size. This marker is kind of crap, but hopefully you can. Let's just go with it. Size, electronegativity, S character, resonance, and induction, right? So the only things that come into play here are size and electronegativity, right? Everything's the same over here, right? That group's the same. It's just this carbonyl group, right? So I screwed this up. So number 3 should not have this down here, right? That's my mistake. Okay. Yeah, now it makes sense. Okay. Right? Yeah. Alright, so that's the way it should be. Okay, so I can tell you it's going to be this one. Size and electronegativity. So, size of the atom bonded to the proton. So for the periodic table we have O and we have S, right? So electronegativity is increasing this way across the periodic table, but size increases down the column. Okay, so SH is more acidic than OH, right? Because S is a larger atom, which helps stabilize the negative charge of the conjugate base. The negative charge has more room to basically stretch out across an atom with a larger radius. So S is going to be greater than O. So this will be the weakest, number 3. Right? And then S, these both have S's. This has extra this. So this group that's attached to the proton is more electronegative than this group, right? It has another double bond O. So what electronegativity does is when this guy, let's draw it like this, when this guy loses its proton, right, it will be R, S, O, O, O minus, right? So this minus charge can be moved with resonance onto all these oxygens, okay? Right, so we could go like that, and then what did that just do? We put a double bond here, turn this into a neutral charge, put a lone pair here, minus charge, right? So we could do that once with this compound, but we could do it twice with this guy, right? Then if we put a minus charge here, right, we could then go back here, we could keep this, and we could go up here and put a minus charge on that O. So there's just more room to delocalize that negative charge. So I guess that is resonance also that comes in there as a factor. Why 2 is more acidic than 3. So this guy's 1, this is 2, this is the least acidic. So we should have in order 2 greater than 3 greater than 1. 2 greater than 3 greater than 1. B is our answer.